What's up, guys? Are you ready for this? This is going to be a fun night. Who's ready? Brian Keating? Let's go. We're going to listen to this.
Threats, Skinwalker Ranch, and skepticism in science and ufology in general. Let's go into the impossible. So, Sean, we normally on this podcast do a deep dive into the cover and the subtitle of a book, and we ask what's the artwork for. You don't have a book yet, although I'm sure people are reaching out to you with many offers. Maybe I'll introduce you to my agent. But I want to instead go over an article that you wrote as the so-called U.S. government's UFO hunter. And that was the title of the article. And the quote I want to get your reaction to is this one that you write: the conspiracist story goes something like this. The UFO has been hiding and attempting to reverse engineer as many as 12 UFOs from as early as the 1960s and probably earlier. The great cover-up failed to produce any salient results, and consequently the work was abandoned to some private sector defense contractors. Apparently the CIA stopped the supposed transfer back to the US government. All of this is without substantiating evidence, but alas, belief in a statement is directly proportional to the volume at which it's transmitted. Sean, what do you say to those people that say that's exactly how conspiracies work? And we're in the midst of many, many conspiracies. How do you react to the criticisms of, well, that's just normal and that's how conspiracies go?
Then why are we fooling around with conspiracies? This is not the Dark Ages. This is back in the land of reason and science and thought, and the way you combat conspiracy theory.
This is hilarious because he starts off with this is not the Dark Ages, and literally my Twitter handle, my Twitter handle for the last year has been documenting the pre-warp scientific Dark Age. That is literally what I've been saying, that we are literally in a Dark Age. And he starts off by saying it's not like we're in a Dark Age or anything. Yes, we are. Yes, we are. We just had COVID. We just had the scientific authorities of the world tell us to trust the science, and they all lied, and they all got caught lying and peer reviewing each other's lies. Are you freaking serious, dude? Oh my God.
And the associated misunderstandings that fuel them is fact and science and truth. So if you've got evidence for a conspiracy, then
Yeah, sorry. I was on mic. I was saying it's funny because they're saying there's no conspiracy.
And that helps to.
Well, the thing is, there's conspiracy theory, and then there's conspiracy fact, and we're not gonna talk any theories on this channel. We're gonna be talking about conspiracy fact and science, and really just talking about scientific fact. I don't really want to talk about conspiracies tonight. I don't want to, try to talk about Roswell or how the head intelligence officer involved with the case said it was a cover-up, or any of the conspiracy stuff. We're going to talk about science tonight, and I just want to let people know that I have a physics degree. I went to Bridgewater State. I have a bachelor's degree in physics, and I've been studying esoteric science and weird technology, controversial scientific topics for about 20 years now, and making videos since 2008. I have a whole YouTube summary here. You can't see my screen. I thought I was sharing it, but I'm not, because again, this is it. I have this UAP technical summary document, which I prepared for the Senate Select Intelligence Committee of 3 years ago, when that was first convened, before AARO was even created. When AARO was created and first created, I said that, oh God, this is a front. The aerospace all domain anomaly resolution office, right? The all domain anomaly resolution office. Why are they looking for UFOs? Why is the conversation about lights in the sky and the recorded data and all that? You know, there was an interesting graph I want to show. This is an interesting graph, and I want to bring this up really quick. It was on X. I don't know how to find this comment now, but it was a graph of giant squid sightings, the frequency of cameras and UFOs. So I saw this earlier on Twitter, and I want to find it now because it's a very interesting graph. It shows a direct, correlation between. Oh, and I can't find this now, man. But it shows a correlation between the sightings of giant squids and the presence of cameras, which is not the conversation that we want to have. We want to have a conversation, why that basically things like Bigfoot and things like UFO sightings have flatlined. We've got high definition cameras. Everyone's got this stuff. Fishermen have cameras, so they're able to capture pictures of giant squids because giant squids are real and they actually exist out there in nature. So if Bigfoots and aliens really existed out there in nature, the theory is that we would see a spike in those graphs as well. But the problem is that aliens have technology like metamaterials and invisibility technology that would enable them to not be seen by cameras, which throws a big wrench in the whole issue. That is often not discussed. And, all this discussion on sensor technology and why it's classified and how it's classified and why we're all, not allowed to have any of that stuff. Yeah, let's keep watching. Actually, I gotta reshare the audio. Guys. There we go. We're going to keep watching this because we're just going to watch like the first 10 minutes because
indicate what the underlying truth is. There has been none that has been substantiated for this. And everything that has been brought to our attention and everything that was brought to my attention when I was in that position as the director, we investigated and discovered that it did not come from where they thought it came from. Most everything was explainable through other documentation, other programs, other people that had talked to other people.
You've, of course, done a lot of research as part of AARO, but also you're a physicist. And I thought it would be very interesting to describe some of the interest that, as I've made the case for, why physicists should be interested. How did you get involved in this project? It doesn't seem to be a likely segue from somebody who was a laser and materials physicist at the University of Georgia. How did you get interested in this? Why should a physicist have anything to say about this subject matter?
Well, so understand that as a career government official, as an intelligence officer, most of my last assignments I was told to go do, not necessarily applied for. This being one of them. I did not apply for this job. So why did they ask me to do it? And the answer actually goes to, I think, where you're trying to head, especially for the students that are going to be paying attention to this. The difference between scientific investigation and intelligence tradecraft is actually very thin. There's a lot of overlap between them. And in fact, we have a field in the intelligence community called scientific and technical intelligence. And it is exactly what it sounds like. It's trying to understand what an adversary, what another country, what anybody else is investigating through their science and technology programs. And you do that by studying them, studying what they're putting out in the publication, studying what actions they're doing, trying to discern what are they actually researching? Why are they doing that? This is not very different from that, in that you have an unknown observation or a phenomena, and you're trying to understand what is that, and is it a threat, and do I really need to be worried about it, or is it something else, and is there another underlying problem that we need to figure out? So the reason I was asked to take this particular thing is because there's not that many PhD physicists in the intelligence community doing analytic work who has stood up programs, stood up new offices and new organizations. So I had experience doing that. I had experience doing research. I had experience doing intelligence work and tradecraft and collection. So in the intelligence community, I would also be known as a collector, an S&T developer. So I would develop sensors or develop experiments to go out into the world and measure what other people are doing, whether that's through remote sensing or overhead or whatnot. Bring all that together, try to understand what's happening.
And you have a background in assessing data, applying likelihood frameworks, et cetera. I've heard rumors, or perhaps they're just, claims that may not be true, that when the planet Venus is above the horizon for some period of the day, which it's not always, that UFO or UAP sightings go up by some very large, statistically significant amount. Is that true, Sean?
I don't know that I have that statistic anywhere. Now, we did do some work, I think, as you know, some work with the University of Utah and my colleagues out there on some correlation math, right? So trying to understand some of the underlying environmental.
Sorry, I just want to stop here for 1 second because there's a couple things I'd like to bring up before moving forward. And that's just, the impact of Venus on UFO sightings. This part is really cringe. Literally, they go into the old debunking arguments from J. Allen Hynek gave for Project Blue Book, back in the 60s and 70s. So this is like really, really just going back on the lies that that the public rejected these lies years ago, and they laughed at them, and Hynek got laughed out of a public convention for suggesting the whole Venus and swamp gas explanation for a whole array of sightings. Now, I believe these are craft that we've been developing. There's a lot of top secret technologies and research. It goes back real deep. Like real deep. We've could have documentaries and documentaries of material. I mean, the Nazis were working on metamaterials back in World War II. A lot of this stuff is as Charles, as Sean Kirkpatrick says, he says this stuff is, does the public have a right to classified data? And let's listen to this. This is nuts. Where is it here?
Spacecraft to other planets. People don't normally think of it that way, but we are sending spacecraft to other planets, right? Satellites, probes, and what.
That's right.
Well, as long as we're having that conversation in the context of scientific research with NASA out in the universe, you're out in the solar system, it's a very scientifically based, data-based, rational argument and discussion, right? As that conversation gets closer and closer to the solar system, somewhere around Mars, maybe a little bit closer than that, science fiction Earth, out of the baseline.
And I'm wanting you to do just one small favor to show that you're enjoying it. It's free. Just subscribe wherever you're listening.
And that's another thing, is there's so many ads and cringe interruptions. It's just like,
to leave a review for today.
Literally just talk about, like,
ask some of my audience taxpayers. Let's grant it. with it as an amateur, and I think, of course, the answer is no. You can make certain images, but to do actual real science, other than kind of just playing around and making pretty wallpaper and screensavers for your desktop, there's very little that an average person can do. That doesn't mean they shouldn't, have access to. But what right does the public have to data? Isn't there some, is there some balance that you try to strike between all these reports that you claim flooded your office, but also transparency to the taxpayer? How do you balance those two competing constraints?
The American public does not have right to any classified data, and we are awash in classified data. We have how many wars going on right now, and every time we take an overhead satellite image from one of our intelligence satellites, that's classified data. You have no right to that. That is
his attitude about how we have no right to this stuff. And Brian, I think, agrees with him completely, because he won't talk about this stuff. In fact, what's really interesting about Brian Keating is I'm going to share this right now. And I invited a couple other people to join us for the conversation. But I wanted to point out that, yeah, Brian Keating contacted me. I mean, I asked him to be on my show like earlier in the year. I think this was in January. Yeah, this was in January. And he replied back, "The truth is, I'm more interested in other topics than UFOs, and I'm doing less of that content going forward." No. Is that true? Is that true? That's not the truth, because if you were going to do less of that content, why'd you have Kirkpatrick and AARO on to show your ignorance on the topic? He said, "The audience capture is just way too powerful. Just look at the vitriolic comments from my appearance with Danny. Pathetic, scorned, butthurt little morons seem to be offended by my analysis, so be it. I was a guest on their shows, Danny and Julian's. I don't have interest in bringing on Sarfati either, and Alvarez was never a UFO scientist. It was an analogy. I wish you the best, but I'm not interested in going through all the reasons why I don't have the time." Okay, good luck. Sure, Brian. All the reasons why you don't have the time. Michael, you gave me a good explanation for these university professors, and that they have tenure, they got classes to teach, and maybe it's true. Maybe it just doesn't have really the time to dig in to UFO tech and really get into the topic. I mean, but
Eric Weinstein talks about this in great detail. But yeah, I mean, you basically have to stick to what the funding is for. And if you step outside that line, you lose the funding. And if you're a research professor, I think Brian's like a mixed research and teaching professor and stuff. So that's just even more work.
Well, all of these things on my list, I have like over 100 slides here of technologies that got lots of funding.
Yeah, so he would take an hour to view it, but then like to actually vet all of that information takes a lot longer than an hour. So
yeah, I know it took me 20 years.
Yeah, and so like if he's a professor, he's got classes to run, he's got research to perform. I mean, like I know like some associate professors like can't take the strain and like even break down sometimes on like they're really being overworked these days, and all the money in the schools is going to the bureaucratic like class that just like manages the endowment, and the administrative class that doesn't actually necessarily they're not experts in the physics. They just push papers and do marketing, and then they do the admissions, and like none of that.
You don't think it's likely that Keating is like knowingly working with the government to cover this up or being disinformation? He's just an overworked, kind of clueless professor who thinks he's being like super scientific and on the right side of this by not looking.
Most professors are that way. I mean, it's possible, a lot of people look working with, I don't know, but like,
I mean, this is all documented physics stuff, though. But it just seems like quacky, and I don't know if it's what it is.
Well, I mean, like you got Herman Bondi there, you got Richard Feynman. Like this is good stuff. Like UNC Chapel Hill, like, but you know, it takes a long time to get into. Like Eric Weinstein, he got into this stuff, and he's like, yeah, this checks out. Like, but like that's the difference between someone who's like out there to discover truth versus someone who's out there for a paycheck, I guess.
Or an
Honestly,
audience,
that's the thing. Like a
YouTube
lot of
audience.
like, there's a lot of politics as well. So like, even if there's something that's true, like people are scared to speak up about it, you know, because they lose their job, they lose their livelihood, maybe they have a family. So that's the thing. We need post-scarcity society so that all the lower rungs of Maslow's hierarchy of needs are met. And if we have a post-scarcity society like that, then people can live to their higher ideals because they don't have to worry about the basics. No, they don't have to worry about getting kicked out on the street if they don't play along, you know. So, I mean, it's a, you know, we have a global oligarchy that keeps everyone in what is effectively wage slavery, and this is a means of control of the narrative of individual people's like. I mean, yeah, you don't really have freedom of expression or freedom of ideas or anything in that sort of world.
I
But
thought it was funny. In 2018, the MIT engineers built that flying electric plane, but that technology is like over 100 years old at that point, because Luigi Rota and Edward S. Farrow were building electric planes 100 years ago and experimenting with some
I mean,
of that.
that seems to have maybe electric motors on that one that they had.
A lot of stuff didn't get the funding, you know. I just or the funding went into these classified programs and stuff that we have little bits and pieces of information about, more than the general public, about these things. I'm learning more. I keep adding more. I just added this to the list today. This was a blimp that was very similar to the Tic Tac in size and shape and characteristics, and it was operational from 2008 during the same time period as the Tic Tac, in the same general area as the Tic Tac was seen. So
Wouldn't have moved as fast as they reported, though.
I want to build a balloon and put it on a tether, like a dirigible, something that we can pull on a tether, because I'd love to test or do some wind tunnel tests of like the airspeed of, you know, how fast you can pull one of these with a tether, you know.
I mean, the speeds they were going, it would probably burn up or pop or something.
Well, that's the thing, right? Is the speeds that this
then, like,
clocked at is in order for it to be a physical object moving through air, you'd need this technology. You need the air spike type technology.
But like, also, weren't they near that island where they're doing the test on ECCMs anyway? So like, or was this in the Gulf of Mexico? I forget.
Right. Well, there's a lot of ECCM technology. This was out in San Diego, just off the coast of Camp Pendleton.
Yeah. Okay. So yeah, out there, you know, they were testing ECCM. So they were probably like testing radar spoofing and seeing how effective it was.
Yeah. Well, they have this whole place out there, San Clemente Island, where they have a whole array of. It's basically like Area 52. It's where the Navy would have moved all this stuff to, because the only people that would see the stuff is like fishermen out there and stuff. It's like it's more remote than the desert in some ways. I mean, definitely Area 51 got a lot of spotlight on it in the late 80s. So it's interesting to think about where they could have moved those operations.
So, but yeah, I mean, Brian's doing his thing. Honestly, he probably doesn't have enough time in his day to look, like, to really keep up with all this stuff is like almost a full-time job, and like, it's out there. There's very little thanks and benefit for doing all of it. Like you know this, like,
yeah,
the stuff gets buried, and it's like, yeah, I mean, he wants to get other things done in his life, and that's just his priority, and that's fine. But I mean, you're not really gonna find real innovation from people like that, and that's a lot of the reason why innovation's been stagnating in recent decades. Is most professors are just like that these days.
Yeah, and you have to be like in order to survive in academia, in order to excel in academia, and also like in the media as an academic in the mainstream media. You have to be that type of persona. Like the wild card maverick inventor types don't fit that role very well usually.
Oh yeah, yeah. I think, yeah, they're not necessarily well spoken. Maybe they have their own concepts about how a thing works and never formally learned a topic, but they do know something real because they were testing it in real life. So, I mean, experiment trumps theory. But yeah, I mean, this is complaining about Brian. It's I don't know if it's.
Well, it's the whole. It's not. I'm not complaining about Brian. Like the whole of academia that he represents is really the problem. I mean, he's got 15K views on this video and YouTube. Like he's getting crazy views, and I used to get 200, 300, 500 people watching my videos. I can barely crack 100 people watching my video on my live streams, and I have over 100,000 subscribers.
Well, I mean, you should start a second channel.
It's crazy. The shadow.
Once you like, just get a separate email, and start a separate YouTube channel and point people to it, and see if you can dodge the shadow ban that way. I mean, the other thing.
But again, this is complaining, and I'm not want to complain. And what I want to do is I want to point out that AARO was a fraud to begin with because it had nothing to do with investigating the technology, the reverse engineering, or any of the real science programs.
Well, I mean,
and it looked for instead the UFO stuff, and they kept the public preoccupied with Jeremy Corbell and like all the mainstream Skinwalker Ranch and stupid UFO bullshit to really dilute the topic and destroy the perception of it in public.
So Sean here talks about how AARO was not tasked with studying the tech, but rather the it's just a threat assessment thing. So the military's like, is this something we should be concerned with? That's what they wanted to know, but you can't really know that. So yeah, I mean, you can't really know that with certainty unless you go into the but then none of these people know that there is a tech side to this to begin with. So like,
that's the problem.
Yeah,
so bitching and complaining about it, like so many people are like, oh, you're just bitching and complaining.
But that's an unknown to them, so they can't do anything about that. It's just the blind leading the deaf or whatever. Or I think I messed that expression up, but you get my point.
The point is that AARO, it shouldn't have been AARO. It should have been another office that formally investigated and subpoenaed, the heads of these quasi-governmental organizations which control all the science in this country, like Battelle, the ones who've been accused of, having the UFO materials sent to them and analyzing them after the 47.
Yeah, and like, they're not even
metallurgy experts over the
they're not even subtle. They're not even subtle with their control these days. Like, like Boeing, they had some whistleblowers and they just assassinated them. They had them killed. Like, that's
crazy.
That's been the status quo for decades. Like, look what they did to Snowden. Look what they tried to do to the guy from WikiLeaks. Assange? Like, they take these people out. Like people who make real positive change for humanity. Problem is, the people in charge.
Who's the fuck are the people in charge that would make those decisions?
Yeah, I would like to know.
Like us trying to change the world and bring science out and lift humanity to greater levels. And it says, oh, these guys need.
Their concern isn't whether or not it's a positive change for society or humanity or the U.S. or whatever. Their question is like, is this good for me? And that is the whole attitude that makes the world the way it is. People got to be thinking about the bigger picture more.
They don't. Brian Keating doesn't. Look what he emailed to me. He said, I'm not interested in this topic. Or yeah, I haven't looked at any of your content. I helped him grow his channel when he had under 1,000 subscribers. Like, I helped this guy like get on the map and build the channel he has and promoted him and he didn't look at a single goddamn thing that I sent him.
Yeah, evidently.
And then he doesn't. He says he's not interested in the topic, but then he's still doing videos on it. He's still
look at
making
that.
videos.
Those top two there.
Look at this.
Like, yeah.
If you're not interested in the topic,
1 month ago, yeah.
Brian Keating, if you're interested in this topic, have me and some physicists on to discuss it with you.
Yeah, even ask
Stop
Eric
talking
Weinstein
retards and Pentagon shills.
Yeah, even just ask Eric about it. Like Eric, we sent him stuff, he looked at it and he's like, yeah, there's something here. Pretty much, right? So
Eric's been watching, he's been checking out. We got NASA scientists on board with this disclosure process, and if there's UFO and alien technology out there, man, I haven't seen it yet, but we're working on it.
And we're close to our initial results as well, too. Won't be long.
I mean, the NASA guy said that they have it. I mean, he says he has propellantless propulsion.
Yes, I don't believe them until we also do it. We need an external. We want a completely separate party to replicate those results.
Right.
And yeah, I mean that thing they got
myself.
That thing they got that would break conservation of energy and conservation of momentum. So that's maybe breaking CPT symmetry. I'm not sure, but it's suggesting, if that's true, it is as big as moving from the heliocentric, the Earth-centric model of the solar system to the heliocentric model. It's as fundamental a shift in our understanding of the universe, because if you don't have conservation of energy and conservation of momentum, what the heck is going? Why is there this universe around us even that seems to have been stable over so many billions of years? How hasn't it just blown up into an infinite energy state or a zero energy, or gone down to a zero energy state if there's no conservation of energy? There's a whole new ballgame.
Where did all the energy come from if there was a big bang that created it all from nothing?
I don't even know if there's a big bang at this point.
Don't know.
Like Curtis Horn was saying, if you think of light at the edge of the universe, it's expanding out from some location. When it reaches you, there's a sphere of matter that it could have possibly interacted with, and that sphere is not centered around you. So if it only sees, for some reason, gravity from the region of matter that the light interacted with, then it will look as if the light has to climb out of a gravitational well in order to eventually intersect with you, so you observe it. So if that's the case, the redshift could simply be some limitation of the interaction of photons with the environment. And that's relating to the ether models we were looking at. You can think of these virtual particles as actual particles, but with a finite extent of interaction range that's associated with the time that they can exist. So you carve out two cones in space time, and that virtual particle can only exist in that spot. So and it can only interact with things that go through that. And so what if light on the cosmological scale behaves the same? So, and I think that's not a perfect explanation of Curtis's idea either. I need to go read his paper better. But and then they're taking all these photos with the James Webb Space Telescope these days, and they're like, oh, okay, if the universe had a big bang, we should see proto-galaxies at the distance. We shouldn't see fully formed galaxies, but they're seeing fully formed galaxies at 13, older than well, no, not quite older than the age of the universe yet. Maybe there were a few, I forget, but yeah, there's galaxies out there that are they should not be that complete and that well formed that long in the past if there was a big bang. So that's suggesting that it's just a redshift by some other means.
Oh,
and
but
so
the astrophysicists, we have to listen to them, because they're the authorities on this subject, right?
Well, I mean, you never trust centralized authority in general.
Jeez.
I generally agree with what's the fellow's name? Noam Chomsky. He's got some issues, but he has this idea of legitimate authority. So, like, if you're a parent, your kids like running out into the street and there's a car coming, obviously you go get the kid and you pull him off the street, and that's what we call legitimate authority, because you can make a rational argument that another rational person would agree is like, this is the right thing to do in this situation. Like if you have two people that are having an honest conversation, an honest argument about that, and you can prove that this is the correct decision, that authority is legitimate. But you can't just have someone who's like, I am the science, or I am the authority on this or that matter, so you just take my word as gospel. That's just religion. And that's been with humanity for millennia. So people fall into that state easily without even realizing it, because it's an evolved feature of our psychology. And when we do that, it's there's a lot of computational complexity that we offload into that. Even when we just have a platonic ideal of what we're talking about, like we have a concept of a chair or a table or a utensil, a spoon or whatever, and these concepts allow us to simplify the extremely complicated world around us into something that's understandable. And I mean, religion is kind of the same way. Like, sometime in the distant past, some people got trichinosis from pork, and so they were like, maybe God doesn't want us eating pork. And then so no one ate pork for like 1,000 years, and that's Islam. Well, I mean, there's a little more to it than that, but I mean, yeah, these things, it was a useful thing to know. Oh, I shouldn't eat pork back in the day, but now people prepare pork better, and it doesn't get trichinosis, and then people can eat the pork and be fine. But like back then, they didn't know that, and it didn't matter. They were just following this hard-coded concept. And a lot of modern physics is, unfortunately, people following hard-coded concepts and dogmatic thinking. And that needs to change if our species is to survive in the long term. But yeah, I mean, and there's something to be said for tradition, because a lot of these things still work, but doesn't mean that they always will. Like, traditional values for marriages and things, on average, well, no, actually, I shouldn't say that, because that'll get controversial. But like, yeah, I mean, actually, no, yeah, on average, people were a little more satisfied with the way those relationships go, just because of the psychological dynamics involved in that stuff. And, well, I shouldn't say that either, because I mean, there's too many outliers, so people will get all butthurt about that. So I won't bother continuing that line of. But no, like, let me think of an actual good example here. I don't know. The Polynesians, they would take canoe plants with them wherever they went, and a lot of these canoe plants, they would populate. Like, they would find a new island, they'd plant the stuff there, they'd make a farm, and like a lot of these canoe plants, like they would have a lime tree or something, right? So this was just a tradition. You take a plant along with you when you went out to sea, and people. Oh, where'd you go, Jeremy? I think we lost Jeremy. Huh. Well, I'll just keep rambling then. Yeah. So yeah, I mean, you take a lime tree out to the ocean. It's like a tradition or whatever, but that prevents scurvy with the vitamin C, and like you don't necessarily know the mechanism by which it benefits you, but
Sorry about that.
Everything okay there? Did you?
My whole computer just crashed and restarted on its own.
Weird. But yeah, so I was saying, like, yeah, I mean, like, Polynesians, they would take these canoe plants out with them, and a lot of these had like vitamin C and stuff, which you need in the ocean if you're out for a long voyage. And so they didn't necessarily know why this practice benefited them, but they did it all the same. And then you had like the cargo cults, like they would make a landing site or something, and then they would get airdropped food. And so they thought that if they kept doing this, then they would get more food over time. Like, but then like the preconditions for them receiving that food disappeared. The war ended or whatever, and people moved on. And then they just thought some sky gods were dropping food or who knows what. And so they just kept doing this. And yeah, so like it worked for them for a while. They didn't know why. They didn't have a causal relationship, but they did the best they could, and it ended up their idea was wrong, but they did it all the same, and they built a society with it, and then like they built traditions around it.
Exactly. Yeah.
This is modern science. Like I worry that like
cargo cult
the
physics.
Einsteins of the 50s and 60s and 70s, like all these extremely brilliant scientists, I worry that their brilliant work was handed off to a generation of engineers in the black programs who just weren't of the same caliber as those physicists. And then those physicists were never replaced because around the 70s, you were saying like, Ghislaine Maxwell's father changed the paradigm with peer review.
Can you hear me at all?
Yeah, I can hear you.
Yeah,
you might have been muted a minute ago.
This was a whole chapter in Richard Feynman's book, Cargo. It was like Cargo Cult Physics, I think was the name of the chapter.
Interesting. I haven't read that book, but I could see that being a thing. But yeah, I mean, so around the 70s, peer review came in, and people were just like, "Oh, okay, this has been looked at by multiple people. It's golden." And then you could use that to launder truth and information, and that's what they've been doing for decades. So I don't know. Yeah, it's not a good situation. And then like all of these genius professors that should have been replacing Einstein and Feynman and whatever in more recent years, they all have to chase funding and have to play a political game in their colleges, and they're kind of just spread really thin. They don't have the resources to, like, basically Eric Weinstein hits it on the head. Like, there are no new giants of physics because the conditions for such trees to grow no longer exist, unfortunately. And so all this research got handed off to engineers and other people in the black projects for decades, and now we have a cargo cult, is what I think is going on. And there were things that were fascinating discovered, perhaps, but we're about to lose them, like the Greeks lost Greek fire because it was overly compartmentalized. Like back then, that was a military secret for the Greeks, and they never shared it, and so it was lost. Although recently people have figured out, like, oh, you can make something that behaves like Greek fire if you mix crude oil with pine resin, or even just toluene with pine resin. So you just take the pine resin out of a tree, you just boil off the toluene, and you get a different ratio of them. You mix a little bit of pine sap back in, and you get something. But yeah, like Greek fire, more or less, we've figured it out since then. But
it
was lost for thousands of years.
Damascus Steel was lost too. They didn't have the original Wootz ingots from the mine that had that.
Yeah, and we can make facsimiles today, but it still isn't even the same. Like they claim like Damascus Steel had almost like memory metal sorts of properties, like, I don't know. It was probably just really strong, to be honest. But
I thought it was the vanadium, the trace amount of vanadium in it, but I don't know.
I don't remember. I haven't looked into Damascus Steel stuff in a while, but
I watched the whole thing on it.
Oh, that's cool. But anyway, that's my 2 cents for the day. I don't know how long we want the stream to go, but
yeah, I just I want to talk a little bit more about the physics and what's on the horizon and what I mean, this is all history stuff. It's all history, but it's like just forgotten. And I'm glad that we resurrected this stuff and that I found it over the years and documented, because a lot of this stuff's been scrubbed from the internet. A lot of it's disappeared completely, and they're doing everything.
I mean, some of it's not even intentional. It's just like everyone's like, oh, I want to be an influencer instead of learning physics. And so like there's literally not enough people to carry the torch at the level that there needs to be. And maybe, actually, I shouldn't say that. The ones who can do it are in China. That's the problem. Well, the problem for the US, it's not the problem for the world, I guess, unless China misuses that power, which, I mean, there has never been an empire in history that hasn't misused its power. So that does not bode well, but yeah. Oh, yeah, that thing. So what else is there happening? So Charles Bueller's things making the rounds on the internet. That's been cool.
So, oh yeah, I want to also say that we have a sample now, our own sample of the arts parts stuff, and we got a couple preliminary tests. There was an argument today about destructive testing. We don't want to do any destructive testing to the piece.
Well, our sample's just too small. Like, if you had the original Linda Moulton Howe sample, you could certainly do destructive testing if you destroy a small piece of it. But like, our sample's too small to bother with any of that. There's not even enough material to do mass spectrometry with it practically. So, but yeah, I mean, if other folks want to send out samples, we'll do some analysis. I guess, Jeremy, the analysis will be coming out a little bit soon, a little bit later. I think maybe I should work on Mark with getting that analysis out, because there's there's a lot of that can contribute to that conversation. But anyway, yeah, if anyone's out there who's got more of this sample and wants like legit testing done, it's leaning more towards the the most important thing we got from the sample is kind of like who's the real deal and who's BSing kind of thing, So like our analysis aligns fairly well with George Hathaway and what's the national lab that did it? Which national lab tested it, or just recently? Oak Ridge, I think. You there, Jeremy? I think you're muted. Hello? And Jeremy's gone. Well, it's just me again. I don't know what I'm doing. Anyway, so I guess I will just keep going. Yeah, so there's definitely lead there. I don't recall the exact claims Linda Moulton Howe made, but I vaguely recall something about pure bismuth, which definitely is not the case here. But then again, I don't recall her exact claims about the sample, so I'll just not go too much into that. And what else is there? Oh, there you are. Oh, you just had a call on the side, Jeremy, or something?
Yeah, there was some. I live in a rough neighborhood. There's some people outside and stuff, and I didn't know who they were, so they went away when I went out there. So.
Okay.
Yeah.
So the terahertz gap. So the next, basically, we've demonstrated that the Oak Ridge test, or was it Oak Ridge that tested this thing, Jeremy?
Yeah, it was Oak Ridge. So
yeah. Okay.
Yeah.
So Oak Ridge National Labs result mentioned that there was some lead there. We were able to confirm the lead. Did they mention any calcium, or was that the other report?
Their Oak Ridge report said there was lead.
Yeah, and so we were able to at least confirm that.
Yeah, but only one of the angles showed lead, and it was a small bump. It was a small bump, so they were showing like 60% lead in their like tests and stuff. So we don't have that high of a lead content in ours.
That is well. So I need to double check what the percentages were, but yeah, I mean, our sample did not have the same high lead content that they claimed. So that was interesting. But then again, like, we have such a small piece of the sample, it would be hard to draw a general conclusion. Like, yeah, they're claiming like there's like
40, yeah, almost like, yeah,
it's almost 3/4 of the sample. No, sorry, almost what's it?
38. It's almost like 38% or something like that.
38, something like. No, so the bismuth is 30. No, that's not 38% bismuth. That's 0.38, or that's parts per million or something.
It's over half bismuth. So this.
Well, yeah. There's ours is definitely more bismuth than lead, and our ratio there's less lead than is in this sample, but our sample our piece of it's much smaller, so it's hard to generalize.
Yeah.
So we got. I don't think we saw any iron or manganese, but they had like trace amounts there. Our sample's just too small. We can't do mass spectrometry like they were doing.
Yeah,
unfortunately. So I mean, yeah, the microstructure looks the same as much as we can say. We got XRD on it, and that XRD matched, I think. Scroll down. Was there? Did they get XRD on this? Was it the? And the isotope ratio also requires a larger sample. Ours is just too small at the moment to do that isotope testing, unfortunately. I really wanted to do that isotope test, but all the NMR folks said it couldn't be done with NMR. I'm not convinced of this.
Yeah,
you just have to get clever, because magnesium only has one nuclear isotope that has a nuclear spin. So in principle, you should be able to tell the ratio between that isotope and the other isotopes.
I don't think they did XRD. They did TEM, right?
Well, that's XRD there. That's the magnesium pattern for that. They did TEM. Actually, yeah, that might be something we could do if we wanted to do destructive testing, but we're not doing destructive testing, so we can't do that. Yeah, it's. I should also mention just
but the whole idea was
there was that fellow that gave us that stuff from Roswell. I still need to. I forgot about that. I need to get that under SEM too.
Yeah.
Sorry about that, dude. We'll get to it. It's still here. We have it.
The thing is, I don't know what's going on with all that. What we do know is that there may be there is classified work going on with terahertz stuff. We know that.
Yeah. I mean, and we're the last non-destructive test that we can try that hasn't been done here is to get the terahertz on the sample. So if we can get a tunable terahertz source and just scan through the frequencies real quick, maybe it'll levitate like they were saying. Actually, even if it does levitate, I'm wondering if it has to do with the surface oxidation on the sample. So it seems like the sample takes an electrostatic charge really easily for one reason or another.
Anyways, as I was saying, we know that this stuff is that terahertz is classified because this guy was arrested. He was working on the terahertz lab at Wright State University, and took some documents home. And the U.S. Air Force OSI raided his house, took his documents away. We looked up his whole PhD theory. I looked up what he wrote papers on and what he wrote his PhD thesis on, and it's all right here. It's non-destructive materials characterization using sub-millimeter wave imaging. non-destructive terahertz imaging for aerospace applications.
Well, this is all just for testing parts on an assembly line for aerospace quality control.
Yes.
So like they used to do like ultrasound, but that has some limitations.
So
And
is that what the only? So you shine these terahertz waves, and that's what the Air Force is doing. They're shining terahertz waves on parts on an assembly line to see
well,
if there's
not even just the Air Force, like even like when you go on the airplane at the airport these days, the scanners use terahertz.
right. Those
Yeah.
scanners
And so they claim their device can determine the difference between various chemicals, and so they have, in order to be able to do that, they must have a lot of terahertz spectroscopy information that they found over the years. So
yeah,
and like the public doesn't have access to any of that. So like apparently with terahertz, there's an optical spectra for materials, and if you just use terahertz light on stuff, you can kind of tell like, oh, this is chromium, or this is some toxic organic compound, or an explosive, or who knows what.
right. So they don't need a drug sniffing dog or an explosive sniffing dog. They just shine,
the
terahertz frequency at you, and if you shine back purple, it's a hit.
Yeah, it's a very sophisticated, like there's, and like,
but
yeah.
this crazy. What's crazy is that you have Tom DeLonge going on Joe Rogan and telling him that it's that this parts saucer piece that we have is a terahertz metamaterial that when you shine terahertz at it, it floats.
Well, we'll try that very soon now, so we'll see.
Yeah, well, like what frequency, and I don't know how much.
Well, my guess is it's going to be around 2 terahertz based on the size of the bismuth layers in between. But I've heard up to 6 terahertz. So we're going to scan from around 2 terahertz to around 6 terahertz when we get our tunable terahertz source. And I mean, actually, it's hard to get a high power terahertz source, but our sample is so small that it might be sufficient to use a couple milliwatts of terahertz power to get the thing to float, because it's a much smaller sample. So hopefully it doesn't require that amount of energy. But yeah.
Right. So that's one interesting experiment that's underway, where it's unknown science, or we're still experimenting with it.
Well, not known to us. I'm sure that I'm sure that the defense contractors and stuff know this stuff already.
Well, some new science too, like this stuff about spin glass theory and strange metals and spin glasses. I thought that this is really fascinating stuff, because you could potentially, make different types of materials, like as Schul was it the guy from Stanford, right before he died. He died just recently. Shulgin, not Shulgin. What the heck is his name, and why isn't it on here? Strange metals. He said that strange metals are similar to extremal black holes.
I think that was probably an analogy by.
No, they're topologically equivalent. He did a whole physics thing on this. He said, well, that's
still a mathematical analogy. It's not like they have the same mass as a black hole or anything. It's a
right.
There's some mathematical thing between them that's the same. I don't know exactly what it is, but I mean, maybe the surface
equivalent.
Well, maybe the surface of a black hole behaves like a strange metal, because I know that the surface of a black hole has a finite electrical conductivity, which is interesting. So if you take 2 electrodes and you stick them on a black hole, you pass current through it. The black hole is actually electrically conductive. I wouldn't recommend it though.
Susskind. Lenny.
Yeah, that was Susskind. Yeah, that's the guy. And so that was more of a holographic principle kind of thing when he was developing all of that.
It was in this lecture right here from 2 years ago. It was one of the last lectures he gave. Man, this is good stuff.
Oh, did something happen to him, or
he died?
Oh shit! Where have I been?
Lenny Susskind is.
Is he still?
Look, let's see. He's no, he's not dead.
No, he's not dead.
I thought-
Although he might be retired, it's always possible. I doubt it though. I think he enjoys teaching, if I recall.
No, crazy. I'm sorry for saying that. I thought I heard he passed away, or that
No, he's still around.
still kicking 84. Man,
Or they haven't updated the page yet, but
it'd be great to interview him, man.
that would be cool. Yeah, I wouldn't understand anything about the holographic theory.
Yeah, I want to
But-
learn more about that, man. He's deep on all that stuff. So
Yeah, and then like the other thing with holographic theory that I don't really get is it's in an anti-de Sitter space, but we live in a de Sitter space. So what's the holographic projection? You know, it's unclear whether the same mathematical concept even applies in the type of space we're living in. So, or were we living in anti-de Sitter space and it only applies in de Sitter space? One or the other things. But yeah, I mean, something like holographic theory is probably true. We know also that like entanglement has and entanglement entropy as well have a very fundamental connection to gravity. So there's this entropy that's associated with gravity, and actually that's like with David Chester, we're collaborating on that a little bit. We're looking at a model right now where electromagnetism is actually unified with thermodynamics before you unify it with gravity. And so you've got this idea where like the electromagnetic potentials, you can represent the magnetic vector potential and the voltage with something called Hertz potentials and Whittaker potentials instead. And when you do that, you get something called stream potentials as well. And those look like Abrikosov vortices in superconductors. And then you also get
right, that's the idea. That's the idea behind the strange metal is they took a YCBO and they perforated it with a whole bunch of holes in it, and what it does is it creates all these vortexes in the geometry, like the topology. Same.
Right. So the charge carriers are bosons, right? And that's required, I guess, for superconductors because, well, no, it's not actually. There's other cases where things become superconductors, so it's a little bit
already a superconductor. It just changes. It makes it turns it from the ordered. I don't know. It talks about this. It's very similar to this quantum chromodynamics, disordered state, quantum critical state, and then the ordered state.
Yeah. Well, anyway, yeah, there's a.
Well, that's interesting. I know that we talked about polariton condensates as a method for producing negative energies.
Well, yeah, I mean, and I should mention that, I mean, the long carrier life, like the long lifetime of the state and the fact that it switches between photonic and electronic allows it to have higher nonlinearities. And that's the high nonlinearity is what gets you all of the interesting physics. And so a lot of people, I've actually been reading up on Tom Bearden recently because I realized the more I learned about statistical mechanics and extended electrodynamics, the more Tom Bearden actually makes sense as opposed to making less sense. And so I was surprised, like he's talking about a lot of the same stuff that we're talking about now in terms of unifying thermodynamics with electromagnetism. Like a lot of the over unity devices he talks about are just cases where you have a nonlinearity, and then you have parametric pumping, which controls the nonlinearity. And, the parametric pumping grows exponentially, and the nonlinearity stables the parametric resonant state. So you get this thing that tends to grow exponentially, and you have something that de-amplifies it exponentially, and then you have this stable state that is formed.
Yeah,
and they're claiming, like, if you have a parametric system, then so like there's two things. Like a lot of the free energy devices, people claim, oh, well, it's just reactive power, so it's not real power. And the thing is, if you have a parametric system, now you're talking about
they say that cold fusion is just hydrogenization of the material. The energy goes in, and the hydrogen goes in, and it creates heat. So it's like it's a
Yeah,
whole.
I mean that is one theory for that, but that's not really what I'm talking about with parametrics. So,
Yeah.
so if basically,
understand the parametric stuff until we get the Shive wave generator going.
Yeah, that'll be a really good teaching tool for at WPI, and hopefully we can show it off as well on the channel here.
Yeah.
But the principle there is you change a parameter so if you're like a kid on a swing, someone can push you from behind. That's direct driving. You have a function that's a driving term on your differential equation. But if you kick your legs out, the swing still starts swinging, and that's because you're changing the moment of inertia of the pendulum, and that moment of inertia of the pendulum is a parameter of that differential equation. So you can have a driving term in a parameter, or you can have a driving term across the equal sign in your differential equation. You can just have a function that drives it. But when you have a parametric drive on your system, now the definition of reactive power actually is changed. So it's actually a little bit unclear whether you have reactive or real power as you're changing the parameters. And so if you can make reactive power and then convert that into real power, maybe you really can make something that's over unity. And then also Tom Bearden specified that these are open systems, they're non-equilibrium steady states, and they effectively are like refrigerators or heat pumps. So if you unify electromagnetism in a weird way with thermodynamics, then you can imagine having like a heat pump where instead of the output being thermal energy, the output is electrical energy. And if you can do that, you can have your input, they call them exciters or tickler circuits, and you have this input, and you have your device, and you have an inflow of energy that will happen once you give that input. And that inflow of energy, the device cools down, and it converts some of that thermal energy into electrical energy. And then the output is the electrical energy that you put in plus some electrical energy from the environment. And so if you can do that, then yeah, I mean, that solves the energy problem for the Earth. And this is probably why like oil companies were like killing these inventors left and right, or trying to pay them off, or give them some hush money, or buy their patent, or scare them into not talking about it, or threaten their families, or like basically like Saudi Arabia and other places, like they run like a mafia in terms of oil. Russia also, like anyone who's got a lot of oil money has a lot of interests in not seeing this technology happen, even though overall for the world it would be a better thing. And I mean, I should stress, like some folks, even in our group, are still like thinking like, oh, was this a government thing? No, it's a corporate thing. Like, and that's the thing. Like in our society, we tend to implicitly trust corporations and not trust the government. The truth is you should never trust concentrated power if it does not make a coherent argument for why it is correct in some case. And yeah, I mean, our government and our corporations have not been accountable to the people for a long time. Anyway, we're just about an hour, so maybe wrap up.
Yeah, well, I was gonna say, we know that Lockheed Martin funded research into the polarizable vacuum theory and how put-offs work with Bernard Hayes, back in the late 90s, early 2000s.
Yeah.
We don't know how far they've gone in the last 24 years, though, with the space-time metric engineering, which we heard about again in these U.S. Navy patents with Sal Pays and whatnot. And we've finally interviewed Sal Pays last year, which was a great interview. If you guys haven't seen that, You should go check that one out.
Yeah, I mean, he really knows. Well, I mean, at an engineering level, he really knows his stuff. I mean, some particle physics might not like it, but no, at least he gets the dimensional analysis and all these things, and like that's the key core component to understand is all of that, at least for engineering purposes, you know. So
this is literally what Brian must think my channel is about. He hasn't even he doesn't even look into any of the information. He like the series alien scientist. Well,
yeah,
it's crazy. I don't know what's going on with why there's so much great.
Oh yeah, this moving mirror thing. That's actually really cool. So
yeah, that was in the end of a formerly classified document by Eric Davis, written for the U.S. Air Force. So
yeah, well, so like we just like Mark, I think recently, maybe we'll let him talk about it next time. But
the crazy thing
he just recently tested an asymmetric Casimir cavity device, and he saw a force. So literally, like actually, you might not like this, Jeremy, but the first place I heard about the cavity structure effect was on what's that dude's
Hutchison?
No. What's the fellow that's kind of weird, but that dude that was working with Corey Goode back in the day.
David Wilcock.
Yeah, for real. He mentioned the cavity structure effect like what, 3 or 4 years ago? Yeah, I don't know. That was weird. I do keep up on his stuff these days because every once in a while, like maybe it's because a broken clock is right once a day. I don't know, or right twice a day.
Right, huh?
Words, but like yeah, it's super weird. Like sometimes he just comes out with something that's like, oh shit, he's not lying about that one. So I don't know.
They probably got guys throwing him real information because like he could just knowing that.
Toss in a grain of truth with a bunch of lies, and it's the best way to brainwash the public. Yeah.
Well, dude, because if me and you hear something scientific from him, even if it's right, if it's real science stuff, if it's right and it comes from David Wilcock, people like me and you will be like, write it off. I would write it off.
Yeah, exactly, and that's why I don't do that anymore because, like,
I know, right?
Wilcock. yeah. No, it's the weirdest thing. That's where I heard about the cavity structure effect first. And then like Mark went out to that conference where he was talking to someone who claimed to be like a 20 and back program guy, and that guy was talking about cavity structure devices too, that thing that makes the gravity in the ship he was in, and and now Mark was working with a guy out in New York City who just had this random idea one day. They're like, what if we make an asymmetric Casimir cavity, and then he tested it just recently in Mark's lab, and we should let Mark go into the details because he'll enjoy talking about that stuff. But yeah, like it's just a weirdly shaped Casimir cavity, and it seems to be perpetually applying a force in a direction similar to Charles Bueller's device. But that suggests to me that Charles Bueller's device is doing something similar. I think that with Charles Bueller's device, you got the structure on one side, you got a flat plate on the other. And when you put the electric field on that, then the electric field is actually modifying the vacuum ground state at the two plates. So that the electrostatic pressure probably cancels out, but then the actual Casimir pressure on the two plates becomes unequal because the Casimir cavity is asymmetric. And that could explain sidereal radiation. Thomas Townsend Brown was researching that back in the day. I mean, Charles Bueller's device looks like Thomas Townsend Brown's device. But anyway, sidereal radiation, the idea there is like the force that Thomas Townsend Brown was seeing out of his devices depended on the time of day and the alignment with the moon and all these things. Well, if you have a kind of a gravitational ground state that controls the amount of vacuum noise in a given location, that's going to control the amount of Casimir pressure that you see at that location. So now you're thinking now what that has me thinking is you could have like a barometer for your current gravitational environment state that's like a asymmetric Casimir thing in a in vacuum that just spins up at a different speed depending on the vacuum ground state. But anyway, yeah, no. So things are getting crazy. Yeah, I would expect us to have some interesting results to share, actionable, interesting results within a month or two, probably. Oh, you're muted, Jeremy, or at least I can't hear you on my end.
That's if David Wilcock and Stavati Aerospace don't beat us to the punch.
I think what happened probably, if I had to guess, they probably also partnered with Charles Bueller before it was well known, maybe, and they thought they were going to get kilograms of force out of the device, but they were never able to optimize it to that degree. And so they probably ran out of runway and ran out of funding trying to get the thruster to produce enough thrust, but it just doesn't produce that level of thrust. That's my thought on the matter.
Yeah, by the way,
if that's all real, but that would be weird, man. That yeah, and I mean he also claimed something about a lawsuit, so I don't know. Maybe some investor thought he was being it was a fraud, and then that got bad. Ugh. But yeah, I mean,
I don't think Wilcock's going to beat us to this stuff. This is you
well,
see videos.
No, yeah, he's stuck right now. He's stuck. It's not. But yeah, I don't know if this stuff all.
All right, Mike. I'm tired of being interrupted every time I try to talk. So I
Oh, sorry about that. Go ahead.
I wanted to say that David Wilcox called 911 in the animal control to report about Steve Cambion harassing him and stuff. This is like a funny whole bunch of stuff that came out, and he also called the fire department. Steve Cambion went and got all these audio calls and 911 calls because he FOIA'd the police department for all the records and stuff on this. Apparently David Wilcock called up the fire department. We get the whole phone call, and he asked the fire department to come change the batteries in his smoke detector because his smoke detector has been going off all night. So if he can't change the batteries in a smoke detector, I don't think he's going to beat us to the punch on anti-gravity.
Probably not. That's no, yeah, I don't know what's going on there. I'm gonna stay out of it myself. But
yeah, it's wild. It's a bunch of craziness. But
yeah, I mean that stuff's interesting, but it's not.
I would love to still have David on the show. We paid $333 for his anti-gravity course and took it. And I
knew all the stuff already, pretty much. I mean,
all the stuff. I knew all the stuff already. It was all review.
Yeah, maybe he was just watching our stuff and just putting it in there. I don't know, but no, I mean it'll be fun to just have him on.
I would like to know where he got some of some of that information. It'd be nice to, but I don't know if he'll share some of it.
Nah, they're not gonna. No, and even it could still be a disinfo campaign of some kind. It could
yeah,
it could be trying to get us to not believe that. So it's. I mean the best course of action right now for us is to just keep plowing forward with the science until we get it.
Yeah, because you don't know who to believe or what to believe, so you just have to test it.
Yeah, and even also with the sample too, Linda Moulton. I mentioned earlier when you dropped off the call, but Linda Moulton Howe, didn't she say that? And I might be wrong about this, but didn't she say that the bismuth was pure and the magnesium was pure or something in the sample?
Yeah, she said it was
pure bismuth and magnesium.
Isotopes too, and they're saying.
Well, I mean, we can't verify the isotope information, but I think I don't recall exactly, but I think she said that the stuff was pure bismuth and magnesium. With atomic precision or something.
Right.
I don't know. I don't know if I believe that.
And Hal Puthoff said something similar, and he also cited this. I
mean, I guess it is relatively pure, but it's not 99.99%. So pure in a sense. Oh.
Yeah, you know this paper by Victor Podolsky. He's I think UConn or something, maybe Princeton. But he wrote this paper where they have this metal and a metal with a dielectric filling, and this acts like a waveguide, and it talks about wave propagation and imaging and non-magnetic LHMs, left-handed metamaterials.
Right, but that's the paper. So basically, like I think it might have been Sarfati or Puthoff or something, but
Mm.
there was another paper from Japan where they showed like there's a single layer of like a single monatomic layer of bismuth on top of some substrate, and that was behaving like a terahertz waveguide, some sort of like spin-spin interaction was going on or something. But
Oh, I got to find that paper. I want to put it in
yeah,
next slide after
yeah,
this.
that'd be good. But like this thing with the dielectric in between, yeah, of course it'll behave like a terahertz waveguide. That's not. But then also the other thing is like this. The bismuth layers are really thick. The bismuth layers in this thing are like 3 to 5 microns or something.
Right.
That's thousands or tens of thousands of atoms. That's a lot.
Yeah, they're not atomic thicknesses. They're not
Yeah.
nano real atomic scale stuff.
Yeah, and I don't know if it matters for terahertz radiation because, I mean, the resolution limit of terahertz is in the micron range anyway. So it might not matter for the terahertz whether it's a single atom thick or 1,000 atoms thick, because it might not know the difference, sort of, or might not see that. It might not matter for that particular thing. Yeah, here's the vibronic coupling. This cool stuff. And these are some of the ways you can get nonlinearities in your system. And then there's like down below, there's the topological states of light there. So I think at this point, if you click on, for some reason, oh, there you go, spatiotemporal optical, spatiotemporal optical vortices. Like so this, it's the weirdest thing. It's been discovered like 7 different times now. People call it like 7 different things. So like there's spatiotemporal optical vortices. There's
Flying donut pulses.
Flying donut pulses. There's vector vortex beams, Majorana photons. All of these names for this at this point, and it's like everyone just wants credit for it or something. It's the weirdest thing. But yeah, this is fundamental because we like mainstream physics is saying, photons just have 2 polarizations, like vertical and horizontal. But this object, you could think of it as a different polarization of light, but also there's a whole family of optical structures of arbitrary genus in terms of topology. So you could have a donut, you could have like the number 8 with 2 holes in it. You could have 3, and they called it photonic molecules in one paper, but then that paper was taken down, so I don't know what happened there. Monatomic stuff. That's
Yeah.
I don't know. I haven't seen much of that. There was a guy on, I think Bernie said he would give us some monatomics to experiment with, but I haven't seen anything from that. There was one fellow who came on board.
Yeah, Bernie, if you're watching, what's up with those monatomics? When are you going to?
Yeah, we'd be willing to test those if they're legit. But anyway, what was I saying? Topological states of light. They also David Chester taught me a new terminology. They have electromagnetic Hopfions. So there's like a Hop vibration, and that is the general shape of all of those possible ones. To monatomics, there was one fellow who stopped by, and he was saying that not only are there 2D materials, but there's 1D materials. So like asbestos, you could kind of think of as a 1D material. Oh yeah. So dilitons. David Chester's work, he was saying if you look at the electromagnetic potentials as being Hertz potentials plus Whittaker potentials, then the Whittaker potential looks like the dilaton, and the Hertz potentials look like the axion. So there's axions and dilatons, and then you get this connection with the Hertz and Whittaker potentials. That stuff connects to gravity, not the electromagnetic fields. So what that's sort of saying is like when we use the Lorentz gauge and we assume that the potentials are 0 in classical electrodynamics, that's wrong. It has to be wrong because there's some physical effects there associated with gravity that we're overlooking. anyway, there's so much going on right now behind the scenes. That's all I got to say. I should.
Oh yeah, I know. And Brian Keating acts like he's the master of all this, and he's the authority, the all-knowing. He doesn't need to watch the alien scientist, and he's not interested in this stuff, even though he does videos on it and still and interviews, you know, the heads of the offices on this. It's just yeah. Anyways, I'm not.
Yeah,
I'm a rant over.
Yeah, I mean we're approaching 1.5 hours, so maybe you want to shut down for the night. I don't know.
We got to write a book. Let's just throw all this stuff in a book. That way we have a book, and Keaton will be forced to read it.
I want to just get some experimental results. That'll be better than writing the book for us, like for society in general. Like we get these experimental results out there based on these ideas, and that's gonna, especially if we do that right, we put it on GitHub, we use Hackaday, we use all the things.
Yes.
That's gonna be a permanent step forward for humanity.
Yes.
Hopefully.
Before we get the dilettante up the
and so like when people there's the scalar field, the Sarfati field, whatever, dilatones seem to be associated with that. And it shows up in a string theory, it shows up with Kaluza-Klein theory. It's this concept is important. And the dilaton, I should also add, it's a spin zero particle. Kind of looks like squeezed vacuum states. So like, what's that about? You know?
Yeah.
Anyway, and then like we have the Aronov-Bohm effect. So we know that there's physical phenomena that the potentials are interacting with, not the fields themselves. So we can't just say the potentials are zero. Oops, I forgot a thing on the stove. You know, actually, yeah. Let's end it for the night. Let me just see if I haven't burned down the thing over there. I better run.
All right. Well, yeah. Thanks for jumping in, Michael. And as always, this is good stuff, man.
Happy to join for a bit. Maybe some other folks have jumped on.
Go check on that, man.
All right.
Thanks.
See you
later. Well, guys, that was some good stuff. Lots of physics for you to look up. So go check that out, and lots of stuff for you to research. Hope you enjoy the physics and a little bit of lesson. You know, I may be only a bachelor's degree and not a PhD, but I have some really smart friends. So it's all that matters, man. We're pushing forward on this and doing what we can, each and one of us, and every one of us. So thank you, everyone, for watching. You guys are the best, and I'm gonna try to get more of these streams and more content going so that I can get these audiences bigger. Yeah, man. It was a little rough start. It took me a little while to get going on some stuff, but man, I really should organize all this stuff and put something together. It didn't need to be an hour and a half. We probably could have covered this stuff in a little bit less time, but you know how it rolls sometimes. Have a good night. Thank you, guys. Keep spreading the word.